All right. Good morning, everyone. Now we're going to look a little bit of a review for right triangles and trigonometry. Okay, that's what this module was about. And we're just going to have a little review, and then we're going to have a small quiz. Okay, so let's take a look. First topic, Pythagorean theorem and applications. So what do we know? For any right triangle, we know that a squared plus b squared equals c squared. Yeah, in any right triangle, we have the legs and the hypotenuse, and then the sum of the square of the legs is equal to the square of the hypotenuse. So let's take a look at some problems with the Pythagorean theorem. We have two triangles, and we got to solve for x. Round your answer to the nearest tenth. Give me 1 second. Let me find my... All right, so let's take a look. What do we have? If I draw an arrow from the 90-degree angle, I know that that's my hypotenuse. So I have a squared plus b squared equals c squared. And then all I have to do is substitute the values. Okay, so a, I could either name this one a and this one b. So 9 squared plus 17 squared equals x squared. And then what do we have? 9 squared, 81. 17 squared is 289. That is equal to x squared. 81 plus 289, that is equal to 370 equals x squared. How do we get rid of the square? We take the square root on both sides. That will cancel my square. And x is equal to 19.2. So that's the hypotenuse in the first triangle. Second triangle, we have this is like a height inside of a triangle, and we have an isosceles triangle. Yeah, these two are congruent. Okay, so this one is also 18, and the height is 13, the one in the middle, this one right here. Okay, so we can name this one y, and we can pick either one of the triangles because they're congruent. And y squared plus 13 squared equals 18 squared. Yeah, 18 is the hypotenuse. Y squared, 13 squared is 169, and that equals 18 squared, which is 324. We subtract 169 on both sides, and that gives me y squared equals 324 minus 169, that is 155. And again, we take the square root of both sides, and that gives me y is equal to 12.4. X, since that is y, this is also y, so x is equal to twice my y, and that is 2 times 12.4, and that equals 24.8. So x is 24.8. Okay, hopefully that makes sense. A little application of the Pythagorean theorem. We have a word problem. A 20-foot ramp is used at the loading dock of a factory. If the base of the ramp is placed 19 feet from the base of the dock, how high is the loading dock? Well, let's create a drawing first. Okay, so that is That is my drawing, and this is my ramp right here. And we know that the ramp is 20 feet long. And that's the ramp. And it is placed 19 feet from the base of the dock. How high is the dock? We don't know. That is x. So it's a right triangle, and we have x squared plus 19 squared, the other leg, equals the hypotenuse squared, which is 20 squared. X squared plus 19 squared is 361 equals 400. We subtract 361 on both sides, and x squared is equal to 39. Then we take the square root, and that gives me x to be equal to 6.2 feet. So the height of the dock, the loading dock, is 6.2 feet. Topic number 2. That is special right triangles. And we looked at 45, 45, 90, 30, 60, 90. So in a 45, 45, 90 right triangle, that we know that this is an isosceles triangle. Those two are the legs, and the hypotenuse is the leg and times square root 2. So the legs are equal. Yeah, it's an isosceles. These two are congruent. And then the hypotenuse is equal to the leg times square root 2. In a 30, 60, 90 degrees triangle, a special right triangle, we know that this one is the shorter leg. S is the shorter leg. And we can call the other one to be L, yeah, the longer leg. And the longer leg equals the shorter times square root 3. And then the hypotenuse is equal to 2 times the shorter leg. So the longer leg equals the shorter times square root 3, and the hypotenuse is equal to twice the shorter leg. So those are some very useful in the special right triangles. So let's look at 2 problems. First one, a 45, 45, 90. So what do we know? We know that in a 45, 45, 90, the legs are equal. So this is another leg. So that is 5. X is 5. And then the hypotenuse is 5. So the leg times root 2. 5 root 2, or 7.1. Okay. In a 30, 60, 90, 30, 60, 90 degrees special right triangle, we have the shorter one is always opposite to the 30-degree angle. So that is the shorter one. And then this is the longer one, y. So the longer one equals the shorter one, which is 9 root 3. So that is equal to 9 root 3, or 15.6. And x is the hypotenuse, which equals twice the shorter one. So 9 times 2, which is 18. So those are special right triangles. Now we're going to move on to trigonometry. So when we deal with trigonometry for sine, cosine, and tangent, we got to remember we used SOHCAHTOA, which means sine is equal to opposite over hypotenuse, cosine equals adjacent, so the side right next to, over the hypotenuse, and tan equals opposite over the adjacent. So those are the trigonometric functions that we're going to use in a right triangle. And we have a little example. We have a triangle SQR. We have two sides, 16 and 30, which are the legs. And we don't have the hypotenuse, so we can call that x. And we can use actually the Pythagorean theorem to find that. So we know that 16 squared plus 30 squared equals x squared. That is 256 plus 900 is equal to x squared. And that is 1156 equals x squared. And we take the square root, and x is equal to 34. So x is 34. Now we have all three sides, and we can find all the trigonometric functions for the given angles. So sine of q, that is equal to 15 over 17, yeah, opposite, sine of q, this is angle q right here, opposite, that is 30 over 34, but simplifies to 15 over 17. Cosine of q, that is adjacent, which is 16 over hypotenuse, which is 34. So that simplifies, if we divide both by 2, 8 over 17. Tan of q, that is opposite, which is 30 over 34, and that simplifies to 15 over, oh, I'm sorry, my mistake, is 30 over 16, adjacent, yeah, and that simplifies as 15 over 8 if we divide both by 2. Now sine of r, sine of angle r, is this one right here. So we're going to have opposite over the hypotenuse, so that is 16 over 34. Divide both by 2, simplifies as 8 over 17. And cosine of r, that is equal to 30, yeah, which is adjacent over hypotenuse, 34, simplifies as 15 over 17. Tan of r, the tangent of angle r, that is equal to opposite, which is 16 over 30, and it simplifies as 8 over 15. And if you noticed, the tans of the angles right here, they're always flipped. Yeah, they're like the opposite reciprocal, the reciprocal of each other. And the sine of q equals cosine of r, and the cosine of q equals the sine of r. Those are some nice properties that if you know them, you can actually very easy use them in problems, and you can use them as a shortcut. Topic number 4, applications, and we talk about angles of elevation and depression. We have two problems. Find the angle of depression from the top of a lighthouse 275 feet above water to a boat 1,324 feet offshore. So first, let's draw a little diagram. So that is my lighthouse, which is 275 feet tall. And this is, and the boat, which is like right here, is 1,324 feet from the shore. And is asking, what is my angle of depression? So this one right here, that's the angle of depression. But what do we know? This line on top, the dashed line, which is kind of like the horizon, and this is, so those are parallel. So this one right here is also of angle of depression. Okay, those are congruent angles, two parallel lines cut by a transversal. So in a triangle, in a right triangle, what do we have? Compared to that angle, we have the adjacent and the opposite. So what do we know from SOHCAHTOA? TOA, that has the opposite and the adjacent, tan. Opposite divided by the adjacent. So tan of x of the angle, we don't know the angle, is equal to opposite 275 divided by 1,324. How do we find this angle right here? We take the inverse of this value. So we take the inverse 10 of 275 over 1,324, and that will give us the value of the angle. And if we plug this in the calculator, this will give us the angle x, which is 11.7 degrees. And the last problem, a rope from the top of a mast on a sailboat is attached to a point 19 feet from the mast. If the rope is 20 feet long, how tall is the mast? Round to the nearest tenth of a foot. So let's take a look. Let's make a little bit of a drawing, and we're gonna so what do we have? We have a rope. So this is my rope right here, and that is 28 feet long, and this is 19 feet. It's from the base of the mast. How tall is the mast? That is x. Since we don't have an angle, we're going to actually just use the Pythagorean theorem from this one. X squared plus 19 squared, those are the legs, equals the sum of the equals the square of the hypotenuse, which is 28 squared. X squared plus 361 equals 28 squared, which is 784. We subtract 361. Oops. And we get x squared to be equal to 423. We take the square root, and x is equal to 20.6 feet. That's how tall the mast is. Now I just want to add one more problem. I didn't include it on that, but we're gonna write it. Okay, so let's say Disney's Tower of Terror ride in Disney World, Florida. Disney World, Florida, is 199 feet tall. If the angle of elevation between Josh and the top of the Tower of Terror is 56 degrees, how far from the tower is Josh standing? And we say round to the nearest foot. Okay, so let's draw a little bit. So this is my Tower of Terror at 199 feet tall. Then we have Josh standing right here somewhere, and we know the angle of elevation between him and the tower, so this one right here, is 56 degrees. And we don't know how far is he from the tower. We're going to have to find that out. So this is, in comparison to my angle, this is the opposite side, and this is the adjacent side. So we're going to use the tan. So tan, which is opposite over adjacent. So tan of 56 degrees is equal to 199 divided by x. How do I find x? We're just going to switch tan with x. So 199 divided by tan, 56 degrees. If we plug that in the calculator, we find that x is equal to 134, round to the nearest foot, feet. So Josh is standing at 134 feet away from the tower. This concludes our lesson. So hopefully this makes sense. All right. So please make sure to email me with any questions if you have. Like I said, we're going to have a short quiz. Okay? See ya.